Okay, good afternoon, and welcome to this talk about microservice patterns. The demos will be done by Eclipse MicroProfile, so it's an introduction to Eclipse MicroProfile as well as a walkthrough of some microservice patterns. And we'll start fast and go faster after we go because there's a lot of stuff to show. So about me. My Twitter handle is there. That's the easiest way to meet me. I'm a principal consultant for Cybercom, which is a consultant company in Sweden. I'm also involved in the Java community process in the executive committee there. And I'm in the Jakarta EE worker group working with the new Java EE, which is at Eclipse Foundation, called Jakarta EE there. We're having a BOF later tonight, so after some whiskey, you come to our BOF and talk about Jakarta EE there. I'm also a NetBeans committer at Apache Foundation, and I run a local Java user group in Malmö. And I'm a Java champion and an Oracle Groundbreaker ambassador. So that's about me. So what we're going to do today is go quickly through a little bit of introduction. It's more or less one slide. Then I'll go through the patterns. It's 8 or 9, I think, of them. And then I'll sum up very quickly at the end. And each pattern will be demoed with some code. So Eclipse MicroProfile is a open source project. It's run at the Eclipse Foundation. It's a web page called microprofile.io where you can get all the stuff you need to get started. There's a starter there, so you can just click start, select some options, and download a zip file, unzip it, and run it. So it's really easy to get started. It's an emphasis on contribution. It's a lot of vendors involved. It's open source. So just microprofile.io, that's where you go to find out about MicroProfile. MicroProfile is a set of APIs. It's a set of standards, and it's built on Java EE technology. So you have the Java EE standards at the bottom: CDI, JSONP, JAX4S, and JSONB, which is Java EE 8. But these 4 standards are something that we believe that is needed to create a simple microservice. But on top of these, we have all these other needs for microservices, such as fault tolerance, metrics, security in form of JSON Web Tokens, health checks, configuration, etc., etc. And these are covered by specifications of MicroProfile. And there are also a lot of implementations, and I'll show a lot of them here today. So the APIs, all the projects are described on microprofile.io. And the current version is 2.2. I think there is a 2.3 coming out in June. And there's also a plan for a 3.0, but they're discussing how to build it because it's growing, and you want it to be modular and simple, but also cover a lot of things. And MicroProfile is, you can kind of say that if you take these specifications for microservices in MicroProfile, put them on top of these Java EE specifications, you basically have Spring Boot, more or less. You can think of it as a Spring Boot just in the Java EE world. So the patterns I'm going through today are 8 patterns. First, I'll go through the microservice architecture pattern, which is actually 3 different patterns I'll talk about. I won't show code there, and then I'll show all the others from configuration, health check, metrics, circuit breakers, access token, tracing, and service per container. And I'll show demos for each one of them. The microservice patterns, it's a book by Chris Richardson. It's a website called microservices.io where you can find all these patterns and descriptions of them. And I'll zoom into this as we go along so you don't have to read all these small boxes. So, microservice architectures. It's not a silver bullet. It has several drawbacks, and most of you are probably doing some sort of microservices today, so it's nothing new. It's not necessarily that microservice is the way to go. You can still do a monolith and apply some of the principles from microservice architectures. But microservice architecture, this pattern is more or less just a collection of patterns for creating this kind of applications. And the patterns I'm talking about today are the monolithic architecture versus the microservice architecture, and also I'll mention database per container. So the structure of this talk will be that I show the pattern where it belongs in this, then I'll talk about the problem statement, and then I'll show how it's solved in MicroProfile. So the problem statement for microservice architecture is what's the application's deployment architecture. And here I'll show some different approaches. You have the monolithic architecture, which is you treat your application as one unit. You can divide it up in modules and nicely layered application, but the important thing is, as I said, you treat it as one unit. And that means if you do a change in somewhere in your application, you have to redeploy the entire thing. And another characteristic of monoliths are they often share a common data source. So you have this dependency on your database or whatever you're using to store your data. So if you change something in your database schema, you probably have to redeploy the monolith as well. As opposed to microservice architecture is where you split up the one blob of thing to different smaller blobs of things. And in this case, you have the application that calls the service A, B, and C. The application may also be a microservice, so you can have service-to-service communication, and it's nothing different there. And these services are exposed through typically a REST API over HTTP. And microservices can also be nicely layered and component, and they can be complex, and it can be everything just as the monolith. It's just that they treat one business domain, and they don't share data sources between each other. One big problem many people do when I start implementing microservices is that they still have this big database in the bottom that everybody depends on. So you do a change there, you have to read with all those services, and you actually haven't achieved anything. So microservices, they own their own data, they work on one business domain, they do one thing, and they do it extremely well, and they call other microservices to do other stuff. Pattern number 2, externalized configuration. So this pattern is one of the cross-cutting concerns patterns, and it handles configuration of microservices. And the problem statement for externalized configuration is how to enable a service to run in multiple environments without modification. And that means that you want to build your service once, and then you want to move it across environments without rebuilding it. You just want to configure it and give it different properties. For example, the connection string to the database. If you run it on your local laptop, you want to configure it to localhost. If you run it in a test environment, you want to point it to a test database. And if you run it in production environment, you want to run it, put it to the production database, and you don't want to build your system again when you move it across the environment. So you want to be able to configure it from the outside. And luckily, we have the configuration for MicroProfile. And configuration for MicroProfile comes with the concept of configuration sources. And you have 3 default configuration sources that come for default. And that is, you can put a configuration properties file inside your application. And this is good for developers. When I sit coding on my laptop and I want to run it with my local properties, or add some stuff to my service, I can use a config file that I just edit in my IDE, and that's fine. And then when I move it to a Docker container, for example, I want to set some environment variables in that container, so I can run it in some kind of test environment somewhere or integration test. And maybe when I go to a staging or production environment, I want somebody to set the properties either as environment variables or system properties, and these will override by priorities. And if you have another way of configuring your application, for example, in Git repository or in a secure vault or somewhere else, you can easily write your own config source and have it give it a higher priority than all of these, and that's what your application will use. So let's jump out to the demo. And in this particular demo, I have a super simple application, and this is the same application I will be more or less using in all the demos. And it's a hello world application, so this one just says hello world. And this one is using a implementation of MicroProfile from Oracle that is called Helidon. So if I just run this one first to see how it works, I can run it from command line like java-jar, as you would expect from this kind of applications. And this is actually Java EE with MicroProfile. So java-jar, that's the way you run the applications. And this one is called configure Duke jar, and it starts up pretty decent quick. So it's up and running. And if I go here and refresh this one, it should say hello. And that's what my application is supposed to do. So let's add some configuration here. So if I go in here and I inject a property called place, and I give it the @config property, and I give it the default value world. And then I can use this variable in my my application logic and rebuild my application and run it again. So now it's configured with the default value of world. So if I run this one, it's up and running, and it says, hello, Sweden. Okay, it wasn't world, it could have been world, but why does it say Sweden? Well, I do have a local config file here called MicroProfile config properties, which says the place is Sweden. But we're not in Sweden now, so we want to run it with something else. So then I can give it a system variable and say place is Kiev, and run it there. So I haven't rebuilt it, I just restart it and give it a property, and it should say hello Kiev. So this is how the configuration works, and it can pick the properties from different sources. Okay? So let's go back to the slides. There you go. So that was the configuration of MicroProfile exemplified by Helidon from Oracle. So pattern number 3, health check API. And health check API is one of the observability patterns that kind of adds the possibility to observe the behavior of your application. And the health check patterns problem statement is how to detect that a running service instance is unable or able to handle the requests. Think about the probe tests that Kubernetes does when it starts up a pod. It checks, can you accept traffic? So that's what the health check is for. It just say, yes, I can, or no, I'm not ready yet. And it can also be used by a load balancer, or you can use it in your application code to just check the health API before you call the service. And this is covered by the MicroProfile Health API. So let's jump into a demo there. And for this demo, I'm using Thorntail from Red Hat, which is their implementation of MicroProfile. So if I just go in here and I just start the application, it is the same application as I'm using in the other demos. It's just the Hello World application, but this time I run it with Thorntail. So should be up and running. So this one would probably say Hello World. But what I get for free here is a health endpoint as well. And it says, hey, I'm up. So this is something I get for free. It's just there. I don't have to code it or anything. But say that I want to do some stuff on my own to check some things before I return the health check. Say that, for example, I want to check that the database is up, or some simple fast checks I want to do before I say the service is up. So let's add a custom health check here. So I have a Duke's health there. So what I do then is I implement a class that implements the health check API, which is from the MicroProfile Health project, and I annotate it with @health. And then I can use this nice fluent API to just say this is my service and this is what it's doing. I can say that is down until something happens, and then I can after some certain of time I can say that it's up. Or like this one, I'm just saying it's up, and I give it some custom Duke Rocks data. It's clear so far. Yeah. So I'll just, when this one has built, start it up and show that. So until it's up and running, and until the application is kind of started in the application, it may show the old health check because that comes default with the application server. So that's what's coming now, and then my application is ready to receive traffic, and then this check comes. So let's move back over to pattern 4, application metrics. And application metrics is also of the observability patterns. And the problem statement for metrics is how to understand the behavior of an application and troubleshoot problems. And for that, we have the MicroProfile metrics project. And in this demo, I'm using Apache Tommy, which is an open source application server from Tommy Tribe. And I'll show how easy the metrics is going. There is no reason for me to use the different implementation other than that it's cool to use different technologies. All of them support the same thing. But let's do this. Measure Duke. And this one I'll just start. I won't bother with building it. And this one called root exec. So let's have a look at this code. Just verify that it is the same thing that I have in the other. So you see it's just a greeting service saying hello. I've added one annotation though, which is @metered, and I'll show you what that one does. So I can still say hello to the application, but what I also have is metrics. So here I get metrics, and this is on JSON format. If I have the accept content type of text, it will be on Prometheus. So I can use Prometheus to read this directly. And what you see here is I can also filter this on application, and you see the endpoint has been hit 1. And this is the @meter annotation on the greet method that I added there. So if I go in and say localhost 880 hello and hit it a couple of times, go back here, refresh, it should be updated. So that's kind of the application metrics that you have control of yourself. You can just scatter this @meter, @counted, and other annotations around in your application to measure whatever you need to measure. You also have some vendor specific, and that depends on which vendor. This is Tommy, they've added the start time property. And then you have the base metrics, which is a requirement from the specification. All implementations must give this, so you can actually rely on this, even if you move your application from Tommy to Thorntail to Halidon to Open Liberty or Payara. Let's move on to pattern number 5, the circuit breaker. And circuit breaker is one of the reliability patterns. And the problem statement for a circuit breaker is how to prevent a network service failure from cascading to other services. And you probably have some circuit breakers in your house. So if you have your dishwasher and your coffee maker on at the same time, one of the fuses may blow, and you have to fix something before it will you can close the circuit again. So the analogy is there. And MicroProfile fault tolerance have a built-in circuit breaker. It's some of the implementations are built on Hystrix, and Hystrix is probably the most well-known circuit breaker technology out there. So for this demo, I'll use Pyara, or Pyara Micro actually, to demo the fault tolerance in MicroProfile. So in this application, I have a little bit more code to create this functionality. So let's look at what I'm doing here. So I have this hello resource, which is the same one I have in the other. But what I've added here is a timeout, and I say this is a timeout of 3 seconds. So if something in this code takes more than 3 seconds, I want a timeout to happen. And this timeout is can be used by the circuit breaker annotation. And in the circuit breaker, I can say that, hey, if a timeout or something happens 3 times, then I want this to be delayed for 5 seconds before I do anything else. And then I can try to close the circuit again. And to get this to happen, I'm just having a counter here, and I'm saying the first 3 times this method is hit, wait for 10 seconds. So I'm sure that is more than 3, and just see if a timeout is happening, and then I'll start accepting traffic after that. So if I start this one, okay, sorry. So this one runs on Pyara Micro, which is based on a fork from Glassfish 3, I think, and it did Pyara, and it actually has the entire Java web profile in it, and has all the MicroProfile specifications. So it's a pretty decent, small, very little footprint. So if I look at the, I'm actually going to have some more browser windows here. So let's go over to this browser. I'll have 4 browsers. And I'll go to the localhost hello. Take this one. I'll shoot this in 4 windows at the same time, more or less. So we go there, and as in, remember, it's supposed to take 10 seconds, but after 3 it starts timing out, right? And 5 seconds at last one was already done since the first timeout happened. And now the circuit is closed again and accepts things. So you see, it doesn't wait for 10 seconds before timing out. It just waits for 3 seconds, because that's the timeout I said. And the reason why it's actually saying I'm sorry I can't count and doesn't show a stack trace is that when I compile this, I use this fallback handler, which actually just writes this response. So you can have a fallback handler, it can be a method, or as in this case, an entire class that just handles whatever exceptions are happening. And this is, you normally wouldn't do this on a REST endpoint like I'm doing here. It's just for demo. So usually you would do it on the client side of a service call. So let's go back to the slides. And go to security. And security, or the access token, is a security pattern. And it is the problem statement for the access token pattern is how to communicate the identity of the requester to the services that handles the request. And the reason why we want to do this is that if you have a microservice architecture with maybe 12 different microservices, and if all of these services are going to check that the caller has the right permissions to do whatever it's doing and the right role, you will get a lot of calls going to your authorization service, which is probably an LDAP maybe, or a single point of failure at least. So if you have one call into your application and that does like 12 calls to 12 different services, you would get a lot of traffic to your security or authentication and authorization service. So what you want to do is pass a token that contains enough information for this one to do. And it has to be secure enough so you can actually validate that the token is okay. So just to give some little bit background information, I'll go through a couple of ways of passing this kind of information. And the most familiar one is probably basic authentication. And basic authentication is that you have an authorization header in your HTTP request which has the word basic and a base64 encoded password. So you pass the password in every request. So this is not very secure, but it's very much used around. Then you have OAuth or OAuth 2, which is exactly the same thing as basic authentication actually. You have authorization header, but here you have replaced the word basic with bearer, and you have a little bit stronger encryption on the password, but it's still a password. It's just a password that you don't type yourself, it's a password that your application has. So your application has a lot of passwords, and it also have, when this one has expired, it has a refresher password. So you're sending a lot of password around. But technically, it is the same as basic authentication. And then we have JSON Web Tokens. And JSON Web Tokens is also more or less exactly the same. It's just that the token is a little bit longer. So here you have the authorization, you have the bearer, and then you have the token, which is pretty long. But if we look at it, we can see that there are some dots in it, and I've colored them here, the purple one, the green one, and the blue one. And the purple one is the header. And the header in a JSON Web Token is a JSON object. It's base64 URL encoded, and it contains the algorithm and the type of the token. And then we have the payload, and the payload can be anything. You can add custom elements there, whatever you want to do. It's also JSON object. It's base64 URL encoded. And there are some standard entries, and you have some custom entries. So you can add stuff if you want to add things that your services need. And the blue one is the signature. And the signature is a binary one, and it's base64 encoded, but it's the actual signature of the token. So if somebody changes anything in the header or the payload, the signature won't be valid anymore. And So when we look at this token, if we just decode it and look at it, it will look like something like this. You have the header, which is the algorithm and the type, and then you have some JSON object that has some custom values and some default values or required values that you have to have. And here I've added like Java everywhere and username Duke. It's stuff that you can add if you want to, and roles you can add and things like that. And then it's a signature that is based on this. So let's look at a demo here. And for this demo, I'll use Open Liberty from IBM. And when I have a JSON Web Token, I have to have a token issuer. And in this case, I won't go into the code of actually doing the generation of the token. I'll just start my token issuer service. And this is where it could be Google or Microsoft or somebody who generates a token and that you accept the tokens from. And this one uses the Open Liberty functionality to generate the token. And here I can say what was the port is running. It's on 8191. So I can post on 8191. I think it's authenticate, I call it. So this one generates a token for me, and I'll use this token. We can have a look at it. So just copy it like Oh, sorry. There you go. If I go to JWT, let's go there. .io. Let's look at it here. You can see what I've added here is I have the up a little. So you can see I have the algorithm is here and the type is JWT, and what I've added here is it's Duke and is a group senior. That's kind of my stuff, and I added a custom value called Duke Rocks. So that's stuff I've added to the token, and it's signed for by the token issuer. On my service side, let's look at how I can do this here. Let's go to the correct one here. So what I do have here is the hello endpoint. Oh, wait a second. Secure service. I'm not sure why it's not compiling here. Let's see. Look at it there. So I have a hello endpoint, which is just saying hello world. So if I start this secure service, it will say hello world. I also have a protected resource, which has some interesting stuff in it. One thing is that it has the roles allowed, which is from Java E8 security. And this is where the kind of the magic happens in the contract between the microprofile and the Java E implementation, is that the roles or groups I'm adding here is translated into roles in Java E, so I can use it in my application code to secure my endpoints. I also have a claim here saying get the claim from the token, which is called custom value, and just print it here. And if you remember, the custom value is Duke Rocks. What I also have done is in my application config, I've said that the authentication method of this application is microprofile JSON Web Token, and I declare the roles that this application is using. So I only have one role here, which is senior. So if I open this application on 9080, no, it's, what was the port? 8182. 82, and I go to the hello resource, it will say hello world, because that one is not protected. But if I go to the protected resource, it will say I get a 4-on-1 because I'm not allowed to do this because I'm not logged in. Right? So what I need to do is then to add a token to my request, and let's do that. And let's add a arbitrary token here. There, and then I'll go to my protected resource. I'll call it again, and it still says 401. And let's see in the log what it says. It says that there is a token there, but it's not valid because it has expired. And let's add another token. Let's go over there, disable this one, add this, and try again. And it says still 401. And here it says that, hey, the issuer is Open Liberty, but I'm only trusting issuers from Agile Java, which is my website. So here you can say that I only accept an issuer called Google and not Microsoft or Facebook or whatever. So let's try to add a proper token and take the one that we generated. Sorry, let's go there. Find the token from here. Let's copy it. I probably still have it in my clipboard, don't I? So let's go to my browser. Go in, stop this one. Go edit here. Say that we want bearer, and then the token. That was not the token. Let's grab it. So There we go. Copy. I think I got it. There. Let's save it. So now we have a proper token here, and it should say this is the protected resource, and the custom value that we're reading from the token is DukeRocks. So you can see I can actually get stuff from the token. Let's move on. We have, I think, two more patterns. So I'll show distributed tracing. And distributed tracing is also one of the observability patterns. And that is, the problem statement there is how to understand the behavior of an application and troubleshoot problems. And one very common tool of using is Zipkin. Another one is Jaeger. How many is using Zipkin? How many is using Jaeger? Do you want to see Zipkin or Jaeger or both? Both, okay. Of course. So what I'm doing here is I'll still use Open Liberty, and I'll show how it's done with Zipkin and Jaeger. So let's just start Zipkin here. Start with that one. Sorry? You can see, of course. Let me see there. Now you should be able. So I just started Zipkin on my local computer, so it's nothing fancy there. So I should be able to go in here and see the Zipkin UI. So in my application, the trace Duke has a let me see. The hello world endpoint here is it's just printing hello, yeah, the configure hello world. But what I'm doing here is that I'm using the REST client from MicroProfile to call another web service. And I'm not using it, I'm just printing the details there. It's a service I have running on Oracle Cloud, and it's just there. The way this works is that I created an interface. If you're familiar with Spring Data, you're probably familiar with this. I created a interface which has the JAX-RS kind of annotations that would kind of be the service. So I'm saying this is a resource called birthday, and it takes a query param called date, and the actual service is running on this URL. So I configure it, and it generates a proxy for me, so I can call it directly in a types-up way. So what I'm doing here is just I inject a REST client, and then I can do a call here. And what I'm doing here is that on this class I'm using the @traced annotation, so every method on this class will be traced to Zipkin. And it will also trace kind of child scopes when I'm calling services that are not part of my infrastructure or Zipkin. So what I'm doing here is I'm creating a call birthday service trace around the call to the birthday service. It's just to make it a little bit more exciting. So if I go and trace Duke, so just start my service, and I should very soon be able to go and say on localhost 9080, hello. It says hello world. So if I go back here in Zipkin and just say find traces here, you see it finds my hello endpoint, which comes from the @trace annotation, and it says call birthday service here, which is the call that I'm doing to the birthday service. You can see it, and I get the timing for these calls as well. So by the annotation @traced, I'm getting the first two here. And this local around the code, I'm getting the other one. So you can do it programmatically or configurable, how to do it. If I wanted to use Jaeger, rather, I can stop Zipkin. they're using the same port, so I have to run just one of them at a time. So we have Jaeger up and running there. And there are no traces yet, so I have to do a call. So let's do a call here. And I can go back to Jaeger, and you can see I have the trace Duke here. Let's go find traces, and you see I have the same. Let's see. There, I have the same trace as I did with Zipkin. So whatever tool you're using, it supports it. We have 5 minutes left, and I'll quickly go through the last one, which is maybe the coolest one, and it's called how to package your services. And the problem statement here are how services packaged and deployed. And the usual way is deploying into an application server, and this has a lot of drawbacks because if one of the services blows up, you will get into problems. So we have different ways of packaging Java-based REST applications. It's the thin war. We have the UBOjar. The UBOjar, you know, it's Java-jar, Duke's jar. It's super popular. You have the hollow jar, which is a variant of the UBOjar, which is the Java-jar, the application server version packaged thingy, and then your war. They all rely on the same kind of stack underneath the JVM operating system and hardware, and there are different layers when you put them in Docker containers. So a UBOjar will be a thicker layer, so it will be slower in everything you do when you add Docker to it. Because when you add Docker, you add the layers from the JVM or operating system and up. So if you have a thick application layer and do one little change, it will take time. It will be megabytes rather than kilobytes. But from the outside, it will look like the same. So the interesting thing here, which I'm showing, is when GraalVM comes in, which supports ahead of time compilation. So you kind of create the dependency graph ahead of time when you compile the project, so it will be super much faster to start up, and it will be smaller, and it will be run as a native component. And one product that does that is Quarkus from Red Hat, and this is just a comparison from a typical REST, for example, REST with JPA application. Graal would be significantly smaller than the typical stack, read Spring Boot or something like that. And the same here, startup time will be like milliseconds rather than tens of seconds. And the way it works is that you kind of compile into a native application, and when you do that, you don't really need the JVM and the other things. You just need the Linux part of the operating system, and it gets much smaller. So we have a smaller image, smaller footprint, faster. And I'll demo this. So let me see. So in just stop everything here so I don't have all this running. There we go. So I have the package Duke application. It is the Hello World application. I'll just show the different ways of running it. So I can run this one as a Java-jar package Duke. Run a jar. It will start up pretty fast, but it's still like 1 second. And in this context, that is super slow. So I say that it's 8080 hello. I'll just verify that it works. So you see it says hello world. So let's start this one compile to native. And I won't compile it to native because it takes a little bit of time. But I do have a prepared one here. Package Duke, which is called Package Duke Runner. And you see it starts in like 38 milliseconds. And it's doing the same thing. And the cool thing about this one with the ahead of time compilation is that it actually does it the tooling with it does that. You can do all changes. It doesn't need to do hot deploy, so you can throw away all your tool like JRebel or any tool you're using for hot deploy, because it's so much faster just to restart the entire thing. So it just stops and starts the server, and it feels like it's hot deploys, and it's super fast. So I encourage you to try it out. It's on quarkus.io. So, but I'll show how the difference, because if I create a native image or a JVM-based Docker image, so if I run the JVM version, it starts up pretty fast. Let's run the native version, and then I'll just look at them. So you can see that I'm not lying. I have Jaeger running, but if you see the other two, you see the native one is using 0 CPU. The JVM based, which is Java-jar version, is using 30 while it's doing nothing. And here I'm just using 1.2 megabytes of memory. Here I'm 60 megabytes, and I'm doing nothing yet. If I start doing things, you will see that this one increases a little bit and then falls down again. This one will go up and then stay there and slowly go down before the garbage collector kicks in. So play around with this and see how much smaller they really are. So Quarkus, from Quarkus.io, try it out. I promise you, you will be amazed. So we looked at a lot of microservice patterns and how they relate to MicroProfile, and all of the specifications in MicroProfile implements a pattern of this microservices patterns. One thing I didn't show today is the Open API, and that is all these applications have default generated Swagger documentation for you, so you don't need to do anything, document any API ever again, because it just generates it for you. But that's for another talk. So I went through these 8 patterns. References are microservices.io. The samples are on my GitHub. Microprofile.io is the place to get started. Jakarta EE is a new home on cloud native Java. Come to our buff later today after some glasses of whiskey and have a talk about Jakarta EE. And that's what I had for today. Thank you for listening. And thank you. I do have stickers if you want.